Hello YouTube, FunshineX here. This is another ComputerCraft tutorial. This is number 6, and this is all about the monitor. The monitor is really cool. It's used as a display method to display things out in your world, to give you information about what's going on in your computer. It has a lot of applications. You could display like games, you could display like statistics, as in my Let's Play. If you go check that out, number 8. And number 9 that will be out tomorrow, you'll see how I use a monitor on my sugarcane farm to give me statistics on how my farm is doing and performing. Monitors can also be used just to display text or show different things. So I'm going to show what you can do with monitors now. I'm going to go ahead and go over to the code. This is set up the exact same way as all my other tutorials. I have a disk drive connected to my computer. As I reboot it, it runs my program for me. You'll see there's a monitor API, and if you go on the wiki and look for monitor API, you will not find it. And that's because it's listed under the terminal API. It has all of the same function as the terminal API, but you get one additional function that's kind of hidden. But I'll show you how you can know that this exists. And so you pretty much get all the same functionality that you can write to your terminal. You can also write to your monitor. And those functions being, you can get the size, and that will return a width and a height of your monitor. You can clear the entire screen, or you can just clear a specific line, and that line is wherever the current cursor is. We'll clear that line only. You can write text to your monitor. You can scroll your monitor up or down, so N is like the number of rows, so maybe 4 up, or -4, or -2, whatever many you want to scroll. Do note there that when you scroll something off the screen, it's gone. So if I scroll down and then I scroll back up, anything that moved off the screen is gone, and you'll see a blank line. So you really need to kind of redraw your screen every time you scroll. Set cursor position. This one is going to put your current cursor at the X and Y position that you give it. So this is how you say, oh, I want to write text, but I want to write it to a specific location on the screen. First move the cursor, then write the text. Your monitor has no cursor blinking by default. The most useful I found for this function is when you're actually debugging and writing your program, and you want to know where on the screen you are so you can line things up and make them look good. In real application, once you've got your program written, there's not a lot of use for a blinking cursor because you can't write anything on input anything into a monitor. All the input's done to the terminal. So why would you need a blinking cursor other than to maybe say, the program's not frozen, it's actually running, kind of like a timer or something like that, or a little clock going around in circles, the hourglass, something like that. I don't see a huge use for cursor blink on a monitor, but it's there. It's just a Boolean value, true or false, to turn off and on. Get cursor position will just give you an X and a Y of where the current cursor is. And set text scale. This one takes a value from 1 to 5, 1 being the smallest text, 5 being the biggest text. At 5, you get 1 line per monitor block. So if you go back to Minecraft, this monitor here is a 3x6. And if you did not know, a monitor block scales as you put ones next to it. So it starts out just 1 block, and if you put one next to it now, it's a 1x2. So I've got a 3x6. If I was at text scale 5, I would only have 3 lines. That's how big it is. If I'm at text scale 1, I think you get 5 lines per block. It might be 6. It's about somewhere around there. All right. Well, the terminal API we're also going to discuss here because it's pretty much the same. It's all the same functions here minus text scale. You cannot change the text scale on the terminal itself. And there's 2 functions that are mentioned in the wiki for terminal, redirect and restore. Redirect is designed to take any text that you write to the terminal and instead write it to the monitor on the specified side. Don't use this, it crashes your program in 1.2.5. I'm not sure if it's a bug or if it's something they just got rid of because there's other methods now and they just forgot to remove this or say that it's deprecated or something. And restore is supposed to do the opposite thing, make all the text go back to the terminal. This won't crash your program, but since you can't ever redirect, there's no need to ever restore. So just ignore these 2. I'll show you how to write to a monitor in a better method. Okay, and that's done via the Peripheral API. Peripherals span a number of things. There's some really cool things out there. Someone wrote a GPU to help you write, draw things on the screen, in a better fashion than the normal interface you have here. Someone's written a temperature control, so you can actually monitor the temperature of your industrial craft nuclear power, and determine if it's getting too hot or too cold and output statistics to the screen. That was really cool. But the peripheral we're interested in is the monitor. And so the various things we can do is we can say, is our peripheral present on one of the sides? Give it true or false back to us. And we can also say, well, what's the type of that peripheral on that side? We're interested in the monitor peripheral. There's also a drive peripheral. I've got those attached. There's a wireless modem. All those different types of things that you can connect onto the side. And get methods will return all the methods that you can call that peripheral. So whoever wrote the peripheral is going to say what methods you can call. And again, we've covered what the monitor will let you to call on itself. And here's actually how you actually do that. You do peripheral.call. You specify a side. So our monitor in the example is our top. The method that we want to call, let's call write. And then P1, P2, etc. We only have one thing here is the text, so we would just say hello world, and then just close our parentheses, not add anything else. Right? That seems a lot of work to write something to a monitor. And luckily there's a wrapper, and that's this peripheral.wrap. And what you do is you wrap a specific side, so we're going to wrap the top, and it's going to return an ID and give us any time we want to call a function, we just call methods of that ID. So if we say monitor equals peripheral wrap top, then we can now just say monitor.write. A lot easier than calling this peripheral call. I'll show you how much easier that is as we go down. Okay, and the first thing I'm going to do in my program is get the size of my terminal and store it in WH. It always returns the width first, the height second. And if I were to just call monitor get size, I'd get an error because monitor doesn't exist. I haven't wrapped it yet. Okay. So instead, I'm just declaring some initial variables for that. And now let's see if we want to use the base method to call methods on our monitor. Here's what we'd have to do. We'd have to say peripheral call, the side we want, the method we want, and then the parameter. So if we do that, it'll work. It's going to work fine. And it should display maybe. Oh, there's something. Hold on. Oops, I'm in the wrong programming language. Make sure everything else is cleared out. Okay, good. Should get a test up there. Cool. Test. Up at 1, 1, right? So that's the default cursor position when you boot up a computer. Okay, but that's a lot of work. We won't want to do that. Don't ever do that. Okay, so instead, I've written a function that I call at the very beginning of my program, and it's going to be called the start monitor. And first, it's going to wrap the top. This could be any side, your monitor's on, and store it in the ID called monitor. And now all I have to do is say monitor get size, monitor.write, monitor.clear. So I can call any of those methods just by referencing the ID. You could actually have two monitors and say peripheral wrap right is monitor 1, peripheral wrap left is monitor 2. And you can get the size individually or write different things to each monitor and that kind of thing. To tell you a little bit more about the monitor, it must be touching one of the sides of this computer, front, back, left, right, top, bottom. There's no kind of cable that you can run to extend to a monitor and put it somewhere else. If you want your terminal in a different place than your monitor, what you would need to do is wirelessly network two computers together and have your input terminal send a signal wirelessly to your other computer, and that computer would write to the actual screen. So that's one way you could accomplish that, but note that you have to have a computer connected to the monitor to write to it. Okay, so this is the function I'm calling. It's going to get the size, and let's uncomment this one. to print the terminal size and the monitor size so we can compare them. Oh, that's going to write them here. Okay, so our terminal size, which is the size of this window here in Minecraft, is 50 wide and 18 tall. The monitor size, which remember was a 3x6, is 57 wide and 18 tall. So that means there's 6 lines per block, and let's see, 57 divided by 6 is what, 7? No, 8, 9, a little over 9. So there's 9 columns per block. It's a little bit different, but you can see that they're about the same between a terminal and a monitor. Maybe a monitor is about the same resolution as a 3x7. A 3x7 monitor, same as a terminal. We could check that. Let's give me a monitor, please. Let's create a mode on. You can see it automatically grows, and now if we reboot this guy, let's see if they're the same size. Oh, I went the wrong way. I should have deleted a row. .47. So not ever really truly the same resolution. That's going to bug me, so I have to fix it. Give me one sec. There we go. Back to a cool looking monitor. But you can see that different, screens might have different resolutions, and so if you're writing a program outputting monitor, you should make sure you get the width and the height of the monitor so you can like center your text or know if you're scrolling off the screen and that kind of thing, so that it looks nice. Okay. This one I want to just run really quick. All this is going to do is just get the methods of my monitor and show them to me. And you'll see it's the same list that I had in my code. Right, scroll, set cursor position, blink position, get size, clear line, set text, go. Moving right along. This one, what it does is I'm testing the scale of the screen. So I'm going from Y1, so the top row, to the height of the monitor plus 1, doing a loop, and I'm saying repeat the string star the X number of times, where X is the width. So I'm basically filling an entire row with asterisks. I'm going to write down the screen, and then I'm going to set my current row position to the next one. So it's going to basically fill the screen with stars. And I don't think I uncommented it. No, I did. What's going on? There it goes. Just took it a second. So yeah, so you can see that there's like, what, I don't know, 18 rows, probably on a 3-sided, 3 monitor high, 3 block high. And let's come back to the code, and if we go up to the top here in my monitor initialization, I set the scale. 1 is the default, obviously, so let's set it to 5. That's the biggest text we can go. And see how many rows we get here. 3 rows, and big giant X's, or asterisks. So you see our screen resolution is pretty poor. There's only like 4 pixels per character. Okay, so let's set that back to 1, and also in my initialization script I want to clear the monitor when we start up the program. So I'm going to leave that like that. And hide this one, so I don't need any more stars. And let's go to a scroll test. So what we're going to do here is put the cursor in, kind of close to the middle of the screen. And then I'm going to do a loop 10 times. I'm going to write a star. And every time I do, I'm going to scroll up 1. After I do that, I'm going to scroll down 15 times and then scroll back up 15 times. And you'll see at the beginning it's going to create a staircase, because every time I write 1, the X position of the cursor will increment. Oh, come on. Oh, typed it wrong. There it goes. Okay, so we get this little staircase because it's scrolling up and moving over. That 10 times. And after 10, remember I scrolled it down 15 times. And you're going to notice some of these are going to go off the screen. And then after 15, I'm going to scroll it back up. And you see any of them that was scrolled off the screen are now gone. They're in the nether. They're in the void. Not really, but they're gone. They're not going to just redraw themselves. I would have to redraw as I scroll the screen up. Okay. This one shows blinking on the monitor. All it's going to do is put the cursor position in the very center. It's going to blink for 5 seconds and then not blink for 5 seconds. And again, monitor blinking is not the most exciting thing. And it's gone. Okay. Just want to show it's possible. Not that it really has any use. Okay, the other one I just want to check the Peripheral API, so I want to check if there's a peripheral on the top right or left and what the types are, just to check. And this says that the... Man, I'm doing horrible with these comments here. I think I'm just trying to go too fast. Okay, so true. There was a top one, there's a right one, there's no left one. The top one was a monitor and the right one was a drive. So again, you could detect if you're writing a program for somebody else and you didn't know where they were going to place their monitor. Maybe they put it on their left, right, top, or whatever. You could actually go through all the sides and say, okay, are there any peripherals attached to a side? And if so, are they a monitor? If so, wrap that monitor, or wrap that peripheral, and then we can start writing to it. Okay. Now here's the cool program. This is my screensaver, why I called this the screensaver program. What we're going to do is we're going to have a run loop, and you'll see down at the bottom here, that's the first line of code I call is run. And this run is an infinite loop until and if a certain event occurs. And you've seen me do this loop before. I start a timer, and I'm going to put this at 0.5, sorry. This is my frames per second controller, basically. So this is running a tick every half a second, so we are getting 2 frames per second. All right, okay. And I'm going to change this one back to 2.5 as well. Okay, and yeah, so we start the timer at 0.5 seconds, and then we're going to go ahead and repeat a loop. And every time this repeats, we're going to call that pull event. We saw that in the Red Power tutorial, the Redstone tutorial. That we get these events whenever something happens, and one of those events is when a timer elapses. And remember that a timer, once it elapses, does not reoccur. It's done, so you have to restart that timer every time. But I'm going to get those events, and I only care about the timer event, and I only care when my timer is equal to t, because this is the one I created. There might be additional timers in my program or whatever, you know. And when that happens, I'm going to call this tick. So every half a second, in effect, tick is called. So 2 frames per second, okay? And inside tick, I should redraw my screen every time. If the event is equal to character and the character is x, exit the we're going to exit the loop and effectively exit the program. So that gives me a nice way to close the program down without hitting Control T. And here I'm going to get some initial variables, and I'm going to print something on the screen and move it around. So I want to track where it currently is, and I'm going to start it at the very middle of the screen. And then I'm going to give it an initial velocity of 1 in the x and 1 in the y. So it's going to be moving in a diagonal. Okay, and then I'm going to declare my tick function. And the first thing I want to do in my tick function is restart that timer, because I have to call, restart it every time it ticks. And I'm going to leave it at 0.5 seconds. I'm going to clear the current screen. So anything was drawn before, I want to get rid of it. And now I'm going to set the cursor position equal to the current x position and y position that I want. Now, if x position is greater or equal to than the width of the monitor, or it's less than or equal to 1, I want to reverse the velocity. So this is just toggling. Times by -1. If it's going forward, it'll then go backward. If it's backward, it'll go forward. Same thing in the y. If it's y is greater than the height, or y is less than or equal to 1, then I switch the y velocity the other direction. Then I'm going to go ahead and add the velocity to the current position and in both the x and y direction. And then I'm going to write a little O to the screen wherever the current position was set up here. So in effect, this O is going to move around and bounce off the edges of the wall of the monitor. Okay, so those are all the functions that I declared. I'm going to go ahead and call the run loop, which is going to run forever until the user types a little x. It's then going to clear the monitor, clear the terminal, and return to 1-1. And this is a very good habit to get in your code, is to clear up your program after it's done. Delete everything off the screen and set the cursor position back to the top left so that the next program that runs, can expect it to be there. Okay, so let's make sure I got that good, saved it, and let's run this guy. And we'll see a little O and it's going to start moving at 2 frames per second. Speeding. And when it hits the bottom, it's going to reverse its y velocity there. And let's keep watching it bounce. Hooray! Make sure it bounces off the wall as well. There it goes. Cool. So let's have a little more fun with this guy. Let's set our timer to be 0.1. And what I could probably do is declare a variable as far as my FPS or something. And let's change the x velocity to 0.5 and the y velocity to 2. So now it's won't go left and it'll be kind of bounce in a taller method, if that means anything, and it'll go a lot faster. And here it goes. Kind of silly because what was I going to say? The resolution on these monitors is fairly low, so it kind of wiggles as it goes. Especially since I'm going just half a screen. Basically, it's going to stay there. So I'm going to go ahead and pause that guy. And let's take it back to 1. That's fine. Run this one more time. Okay, now we're getting a bounce. And what I wanted to show is that I can go ahead and stop the program and delete a square of this monitor. Oop, not that one. Remember, it has to be connected one, but I could delete this one. Okay, and now look at my monitor is only a 1x3. Now if I wrote my program right, it shouldn't matter what size the screen is. And see, it's now bouncing inside that little tiny monitor. Okay. And then if I do that, it shouldn't matter what size the monitor is because I've always checked the height and the width of my monitor. So that's another good practice, to just check the height. And you see it doesn't update. It's going to probably bounce back right now because it just thinks the monitor is a 4x4. It will take a full computer reboot before I actually run that code that checks the size again. So maybe that's another thing I could do in my program, is check the size every time it draws, just to make sure that I'm still within the bounds of the monitor. Cool, so that's my screensaver. Make sure my monitor does not suffer from burnout. And just kidding. But it does show all the uses that you can do with the monitor. Again, there's a lot of applications, and you could write games and play games on it. But that's kind of difficult because you have to be in the terminal for it to get your key presses, left, right, up, down, typing characters. And when you're in there, you can't really see the monitor. I've got a way around that. I'm going to be doing something really cool for my 100 subscriber special. So I hope you guys keep sharing my videos to other of your friends, get them to subscribe. I'm not that far off 100, and we're going to be showing something really cool with the monitor, and it'll look very similar to what's going on right now actually on the monitor, but a little more interactive. So hope you guys stay tuned for that. Hit like, hit comment. I really appreciate all the new subscribers leaving comments. It's helped me a lot. It's told me that you guys enjoy what I'm doing, and you're giving me a lot of tips on what I can do better and suggestions on what you'd like to see. So I really enjoy that. Keep doing it. Hope you guys enjoyed my ComputerCraft tutorials. The next one, number 7, we're doing a lot, is going to be all wireless. And I'll give you a sneak peek over here. It's not too exciting yet, but we've got 2 computers, each with a modem on a different side, and one of those turtles that I've shown before that's also got a modem on him. What could I be doing with those? Stay tuned. This has been FunshineX. I'll see you guys later. Bye.